Hey there, class. Mr. Busky here. Hope you're having a good day so far. We're continuing Chapter 3 of Solving Equations. Today is 3.5. Name of the lesson is the Linear Equations and Problem Solving. Our central question is, how do we set up and solve word problems using equations? Alright, so we have a warm-up which we need to solve. So go ahead and see if you can solve it all on your own without me giving any help, and then we'll go through it in a second. Alright, welcome back. Oops. Let's go ahead and solve this thing right here. We have 4x minus 5 minus 3x equal to 2 times the quantity of 5x plus 11. So what's the first step whenever we're solving that I've been teaching you guys? Starts with a D. We need to simplify, which means we need to distribute. And the second thing, which we'll talk about in a second, we need to distribute here first. So we have 4x minus 5 minus 3x. 2 times 5x is 10x. 2 times 11 is 22. Anything else to distribute here? No. What's the next thing we look for? We need to combine like terms. Are there any like terms to combine here? Yeah, we got 4x minus 3x, which is going to be how many x's? It's going to be 1x. X minus 5 equals 10x plus 22. Any other like terms to combine? Nope. Now we need to get all the x's to one side and all the constants or numbers to the other side. So let's get all the x's to one side. Do you guys want to move the 10x or the x? Let's move the x. I'm going to move the x by subtracting x from both sides. So now we have negative 5 equals 10x minus x is 9x plus 22. Next step is to do what? We need to subtract 22. We need to get the, sorry, I kind of jumped the gun there. We want to get the 9x by itself here. We do addition and subtraction first when we're solving. So we need to get, we're going to subtract 22 because we want to get rid of addition and subtraction first. We're not going to divide by 9 first, okay? We've got negative 27 equals 9x. What's the last step to solve for x? We need to divide by 9. X is going to equal negative 3. All right. If that was really challenging for you guys, I would highly encourage you to go back through 3.3 and 3.4 and rewatch those videos, because this should be a skill that you have by now to be able to solve these, okay? All right, today is all about collaboration. Well, not really. This would be for more if we were in class. We would try these problems on our own together. But it's Mr. Posky's patented problem-solving procedure, GAS, which is goal, analysis, and solution. So basically it says, what do I want, what do I have, and then you go. We're doing some word problems today, okay? Some tricks for word problems is always figure out what you're looking for, first of all. Figure out what you have, and then you just kind of set up an equation after that, okay? So here's some tips with word problems that will help you solve these problems. So let's use the screen here. So we replace what we're looking for with what? What do we replace what we're looking for usually with? We're going to replace it with an x. Okay, replace what you're looking for with x. That's going to help you just figure out what you're using to solve for. Then we're going to look for a total. A what? A total. So if you have a total of 60 oranges, your equation should end with equals 60. Equals 60 if you have a total of something. All right, next step is to figure out what operation you are using. Sorry, I got to put my page here. Figure out what operation you are using. So per box, if you have like, $2 per soda and you have 3 sodas, that's 2 times 3, right? So per box means multiplication. And what we got to be careful about is more than and less than needs to go at the end, all right? So 7 less than 2 times a number is not 7 minus 2x. It's actually 2x minus 7. So less than and more than needs to go at the end, okay? Actually, I'm going to write that. Go like this. Okay, so 7 less than needs to go at the end, not at the beginning. Okay, so be careful with that. It says we'll try one together and then do some on our own. We're going to do them all together here. But if you want to pause the video, I would highly encourage you to try these problems on your own and see how you do, and then check your answers at the end here, okay? Just to get some practice, because they are kind of challenging, but do the best you can. Lisa is cooking muffins. This is number 1. The recipe calls for 7 cups of sugar. She has already put in 2 cups. How many more cups does she need to add? All right. So, what are we looking for, first of all, here? What's the question asking? It's asking for how many cups does she need to add, right? We're going to call that X. All right. Do we have a total for this problem? The total is a good thing to look for here. The recipe calls for how many cups of sugar? 7 cups. We're going to put equals 7 over here. And then what else do we know? We also know she's already put in 2 cups. So if we already put in 2 cups, let's start with 2 here. And we're looking for how many cups she needs to add. Well, that tells us we're going to add. So I'm going to do 2 plus X equals 7. That's our equation. Okay? How do we solve this now? What do we do? We subtract, not 5. We subtract 2 from both sides, and X is going to be equal to 5 cups. All right, and very important here. Were you guys able to guess that it was 5 cups without even like figuring out an equation? Yes, you probably were, but that's not the point of this lesson, okay? The point of this lesson is to figure out how to write equations, which was right here. Okay, writing equations is what we're kind of testing on here, okay? So, because like I mentioned in other videos, you might be able to guess what the answer is to a problem, but guessing what the answer to the problem is not the point. We're working with equations, which is a cornerstone, which is a very important skill for solving, for algebra and math in general, okay? So I know that the middle school math is to guess what the number is going to be. High school math is when we write and solve equations using these, okay? So don't just guess what the number is because you're going to get it. That's not what I'm testing you on. All right, number 2, how many boxes of envelopes can you buy with $39 if one box costs $3? All right, what are we looking for? We're looking for how many boxes, right? That's our X. Do we have a total for this problem? Yeah, we got 39 is going to be our total. And it says one box costs $3. So if we're looking for, it says X boxes is what we're looking for, and we have $3 per box. What am I going to write for to the left of the equal sign here? Well, it's $3 per box times the number of boxes that we have, which we don't know. So 3X equals 39. How do I solve for X now? I'm going to divide by 3. X is going to be equal to 13 boxes. All right. Number 3, last week Julia ran 30 more miles than Larry. Julia ran 72 miles. How many miles did Larry run? All right. So Julia, whenever it says Julia ran and then they tell you something else about the other person, we're going to put that person as equal to, and then you're going to write what the comparison is to the right of the equal sign here. 30 more miles than Larry. Well, more than needs to go at the end, so plus 30 is going to go at the end, and we're going to put Larry in front here like this. Julia equals Larry plus 30, or 30 more miles than Larry, right? So that's our equation. That's all we got to do. Julia equals 30 miles more than Larry. But we also know that Julia ran 72 miles, right? Sorry, I shouldn't have given this away here. We're looking for how many miles did Larry run. That was our X. We're using J and L for this one, I guess. Let's use X. We'll stick with X here. We'll stick with that. So J equals X plus 30, okay? We'll stick with the theme from the previous problems, all right? So if Julia ran 30 more miles than Larry, it's going to be X plus 30. And we know that Julia ran 72 miles. We're going to do 72 equals X plus 30. How do I solve this now? I'm going to subtract 30. X is going to be equal to 42 miles. All right, that's how many miles that Larry ran. All right, 2 more examples for these word problems, and we're going to get into some other stuff. So let's go ahead and keep going. 331 students went on a field trip. 6 buses were filled, and 7 students traveled in cars. How many students were in each bus? So what are we looking for here? We're looking for how many students were in each bus. Do we have a total for these problems? Yeah, we got the 331 equals 331. So we had 6 buses and 7 students traveled in cars. So if we had 6 buses and there's X many students in each bus, how do I write that? Well, it's going to be 6 buses times the number of students in each bus, and then plus the other 7 students we had which didn't which traveled in cars. Okay, there's our equation. Now how do I solve for X here? What do I do first? Do I divide by 6 or subtract 7 first? I'm going to subtract 7 first. I do addition, subtraction first. 6x is going to be equal to 324. Now I do what? I divide by 6. X is going to be equal to 54 students. Students per bus. All right, wrapping up the last problem for this, not the last problem for these word problems here, I guess. How old am I if 400 reduced by 2 times my age is 244? So what am I looking for in this problem? What's our x? It's how old I am, right? So x is how old I am, and then what's our total here? Well, we see is 244, that's equals 244. Okay, now we got to figure out the rest of this here. 400 reduced by 2 times my age is 244. So 400 reduced by is what operation? That's subtraction. And what's 2 times my age going to be? Well, if x is my age, 2 times my age is going to be 2x. All right, cool. Now we're going to solve for x. How do we do that first? We're going to get rid of that subtracting 400 divided by negative 2. I would subtract 400. In this case, dividing by negative 2 would work, but I just think it's a good idea to do addition subtraction first. Okay? Negative 156 divided by negative 2. So x is going to be equal to 70 years old. All right, it's like a riddle from an old man. Okay, moving on. Consecutive numbers. What are consecutive numbers? Write some down some examples of consecutive numbers. Consecutive means what? Consecutive championships means in a what? They're in a row, right? Okay, so what are some numbers that are in a row? What about, what comes after 3? 3, 4, and 5 are consecutive numbers. What about 20? What comes after 20? 21 and 22. Okay, these are consecutive numbers, all right? So that's the idea we're trying to talk about here. But it says, what if we do not know what the numbers are and we want to use variables? Okay? So I'm going to call the smallest number, I'm just going to call 3 equal to x. Okay, say we're trying to figure out what the numbers are going to be. This is going to help us do that. Because we could do, or here's 3, 4, and 5, right? We could call 4y and 5z. Don't do that. You could do that, but then you have x plus y plus z equals a certain number. But one thing you got to be careful about, though, guys, is when you're solving equations, you cannot, you have to have one variable to work with here, okay? So we're going to do kind of a shortcut here to help us figure this problem out, okay? So in case we didn't, this is like if we didn't know it was 3, 4, 5, we're trying to figure out if it is 3, 4, and 5. So if x is 3, how do I write 4? If x is 3, 4 is going to be x plus what? How do I get from 3 to 4? It's going to be x plus 1, right? Okay. And if x is 3, then 5, to get from 3 to 5 is going to be x plus what? It's going to be x plus 2. Okay, now we have, these are ways to express the pattern, not the actual numbers themselves, but the pattern that we can use to figure out, like, unknown numbers, basically. Okay? All right, moving on. We've got a couple more here, and then we're going to do an example that will make a little bit more sense. What are consecutive even numbers? So consecutive even numbers are numbers that are in a row but that are also even. So what are the even numbers that are in a row after 2? 2, 4, and 6, or 10, 12, and 14. Those are consecutive even numbers, in a row and even. All right, same thing. We're looking for a pattern here. We're looking for a pattern. I'm going to call x 10. I got to figure out the rest here because we're trying to figure out, we're going to be looking at using a pattern to figure out like how to figure out numbers like from algebra, basically, okay? All right, so how do we get from 10 to 12? If 10 is x, 12 is going to be x plus what? It's x plus 2. And then we have 10 to 14. If 10 is x, and 10 to 4 plus 10 plus what is 14? X plus 4. All right, so that's the pattern for, these are consecutive even. Up here was consecutive. Oops. Yeah, consecutive numbers. Okay, the last one we're going to talk about is consecutive odd numbers. Okay, consecutive odd numbers would be like 1, 3, 5, or 19, 21, 23. Any examples you can think of here? We're just trying to figure out a pattern to be able to guess this later, okay? So I'm going to use 19. So 19 is x, 21, and 23. So if 19 equals x, how do I get from 19 to 21? I'm going to do what? X plus 2. And how do I get from 19 to 23? X plus 4. Okay, if you notice, these are going to be the same. And it's just because they, it is kind of interesting that they're the same. But so this is the pattern that you'll use to be able to solve for unknown numbers. We know these numbers. We're trying to figure out a pattern to solve unknown ones, okay? So let's go ahead and do that here, all right? So for consecutive numbers and perimeter problems, you're going to call your smallest number or side, you're going to call that x. And then you're going to find out how the other sides are compared to x, okay? So let's do number 6 together here. The sum of 3 consecutive even numbers is 48. Find the middle number. What are the other two just for fun? Okay, so what I need to do, give me 3 consecutive even numbers. Well, obviously you can't tell me any, so I'm just going to pick a couple. Let's try, I don't know, consecutive even. Let's do 18, 20, and 22. All right? So our problem tells us to call the smallest number. Let's call that x. How do I get from 18 to 20? It's going to be x plus what? X plus 2. How do I get from 18 to 22? It's x plus what? X plus 4. Okay? So the reason we did that stuff in the beginning is because we don't know what these numbers are. These are not the numbers. They may be the numbers, they could be, but we're not sure what they are. What we did this for is to figure out the pattern that the numbers, no matter what kind of numbers they are, no matter where they are, if they're 322, 324, 326, or 246 or whatever, they will follow this pattern, and this is going to help us figure out what the other numbers are going to be, okay? So let's find the middle number. So it's the sum. Sum is addition, right? So we're going to add these up now. We're going to add up these patterns to figure out and solve for x. So we got x plus x plus 2 plus x plus 4 equals 48. It says the sum of those are 48. Okay? So I added this, this, and this. All right, now we need to solve this. Anything to distribute here? We're looking for all 3 numbers. This is going to help us find those. We nothing to distribute. Any like terms to combine? We got x, x, and x, and then also 2 and 4. Well, x plus x plus x is going to be 3x. 2 plus 4 is 6 equals 48. Now we got to solve for x. How did I get that 3x by itself? I need to subtract 6. And 3x is going to equal 48 minus 6 is 42. Now what? We're going to divide by 3. That's a 2. Divide by 3. So x is going to be equal to 14. So that's our smallest number. We weren't far off. We just used random numbers here. But 14 is the smallest number. What are the other 2 numbers going to be? Well, we're going to count up by 2s like they're consecutive numbers. So 14, then 16, then 18. So these are the 3 numbers by solving that we did here. And this is the middle number like it was asking for. Okay, pretty cool, right? So we didn't even know what they were, but you could also guess. You could have done like, oh, I don't know, 20, no, that's not a good. We could have done 8 plus 10 plus 12 and tried to guess what numbers add up to 48 and are also consecutive even numbers. But by using this pattern, we were able to guess it, or not guess, we were able to solve for it without having to just guess, it saves us some time and energy, which is pretty cool. Okay, if you were doing consecutive numbers, you would do like 9, 10, 11. That would be x, x plus 1, x plus 2. You would do the same thing, except you would plug this stuff in right over here. Okay? And same thing with consecutive odd. It would still be this right for this one because those are the same basically. But yeah, it's kind of a shortcut. All right, last example. It's a long video. Let's get through this here. The perimeter of a rectangle is 30 inches. The length is 5 less than 4 times the width. Find the length and width of the rectangle. It says draw a picture first. All right, let's draw a picture. All right, so we have length. Oops. I'm going to do this for a reason. Width. We know the perimeter equals 30. What else do we know? All right, it also says the length is 5 less than 4 times the width. So we're literally going to write that. The length is 5 less than 4 times the width. So 5 less is minus 5 at the end, and then we have 4 times the width. So we get 4w minus 5. All right? So just do what it says in the problem to do. It's going to help us find this here, okay? So we don't know what the sides are. We're trying to figure out the sides, but we can use that information to figure out what the sides are going to be. So what's the formula for perimeter of a rectangle? Is that the inside or the outside of a rectangle? It's the outside. So if we go around the rectangle like this, it's going to be length plus width plus length plus width, right? Oops. Length plus width plus length plus width equals P. Well, let's combine some like terms here, though. This is going to help us. There's a formula that we're going to figure out here. This is where the formula comes from. How many lengths and how many widths do I have here? I got 2 lengths and I got 2 widths. So it's going to be 2L plus 2W equals P. That's the formula for perimeter of a rectangle. That's where the formula comes from, okay? It's all the outsides added up. So now, we don't really know. All we know is that the perimeter is 30, and we know that the length is 4 times the width minus 5. So we're going to take that, we're going to plug in for the length right here. So we have 2 times 4W minus 5 plus 2W equals 30. So how does this help us? Well, like I said, you are not able to solve an equation with multiple variables. At least you guys aren't at this point, okay? So having one variable, which is just W, is going to make it a lot easier to solve this, okay? So that's why we did that here. All right, let's go ahead and solve this now. So we have 2 times 4W minus 5 plus 2W equals 30. Anything to distribute here? Yep, we got to distribute the 2 to both of these. We got 2 times 4W is 8W. 2 times negative 5 is negative 10. Plus 2W equals 30. All right, any like terms? 8W and 2W is 10W. Minus 10 equals 30. Now we need to get the 10W by itself. How do we do that? We need to add 10. So 10W equals 40. Now what do we do? Divide by 10. W equals 4. Are we done? W equals 4 is one of the answers we need. We're trying to find the length and the width. So now we got to find the length, but the length we know equals 4W minus 5. So we're going to take that 4, we're going to plug it in for W. We're going to solve for the width. 4 times 4 minus 5. Length equals 16 minus 5. So the length equals 11. All right, that was probably the hardest problem on this lesson. So hard stuff, pretty tricky, but just do your best. Watch the video a couple of times, see if it makes sense, and ask some questions in class if you have them, okay? Thanks for watching. Have a great day, and we will see you soon.